Good morning everybody, my name is Marco Walter Bassignana and today we make a video about the first AGV connection. So, the first thing you have to know is that, as explained in theoretical videos, you will need to install on your PC the RAT, the AGV manager. Together with it, you will have the AGV configurator, and you need RDE, the Robox development environment. Then you will need 3 pieces of software. As explained before, we will have the AGV manager. This is a base project we can use. Then here, let's see, inside here there is no map, excellent. Then here I prepared the folder with the standard R3 project. You know that this is the useful project to allow the controller to rule all of the axes of the AGV. This is a pre-developed project already defined in order to control the main axis of the AGV. It uses many, let's say, many standard objects like the object blocks we have developed. And inside that object blocks there are more than 30 years of experience and software and mathematics we have done. Now let's copy the path, Ctrl+C in order to reach it quickly. Let's play open, and I cannot press paste. Okay, it's not important. Here we have, Robox AGV lesson. Okay, I'm lost. Robox AGV lesson R3. Okay. Now that's the project we may see. And so here we have the main configuration. You can see in this standard project we have the 4 axes, which are traction and steer of one motor wheel, traction and steer of a second motor wheel. Together with this we already have traction and steer of other 2 ones. And this will be very useful. Together with this we have the virtual axis of traction and steer. These are some standard used objects in order to control our system. Together with this we have the ethercat, and the ethercat is now using some devices, some 2 motors. They are 4 axes for 2 motor wheels of Tongyi, which is a Chinese constructor. And here we have our object blocks, as I said before, with all of our knowledge and experience, the power set to rule all the axes, and some general settings already done. As we have explained in previous lessons, this project is using 1 rule and 3 tasks. The first is the main task with the OB start, and it stores all the main links we will need to parameterize our system. Together with this we have task number 3, which will handle the communication with HMI, and then number 4 is used mainly for manual motion and some other kinematics commands. Let's say that normally you should not touch these tasks because they are standard. You may just would like to modify something in task 1 according to the structure of your AGV. And inside the rules, you will also would like to add some part, because maybe your AGV will have some auxiliary axes, and so you will need to set something according to maybe conveyors, belts, forks, or maybe also handling of a robot. In case you have to communicate with a robot, it's much more possible normally that you are using a standard industrial robot, and so you will just make a right click, new, object block class, and here we will look for something standard like TCP/IP, and so you will be either a client or a server. This is something I suggest you to do because this is the easiest way to deal with some robot mounted on your AMR, so the AGV together with robot. Finally, in the file in Flash, we have the list of the files we are going to load on our system, and they are already ordered here according to our system. So let's say that mainly this program is something you will touch so few, and today I'm explaining you how, just to make an example. Together with this, in our folder, sorry, it's this one. In our folder, we also have the main AGV manager that we will use to make just a demo program. And then here we are going to talk with the AGV thanks to our digital display, which is the HMI. That's developed using Robox RDE, the Robox display tool, which is our graphic designer for HMI. Here inside, this is already a predefined project, pre-developed. You may download these 3 programs from the internet in Robox SPA website. Otherwise, you may ask to your Robox staff colleagues to give to you the most updated ones. And then we can also help you to do the same thing we are now doing in this video. In case you have any problem, of course, contact us and we will help you to start your AGV. Now, let's begin. First of all, here we have the program we have already opened. But in order to talk about the AGV, first we need to know the structure of your AGV. As we have explained in previous lessons and in previous videos, one AGV is a complete unknown object, because you would like to have many axes and you may have motion axes and auxiliary ones. So first of all, we have to define the structure of your mechanics. To do this, let's take an example and let's look at this picture. Here we have an AGV. It's drawn from above, that's front and that's rear. And in this AGV, which is 4 meters long from the front wheels to the rear ones and 1.5 meters wide from the left to the right wheels, and this is something so symmetrical we would like to use in our sample. And now let's imagine for this sample we just have one AGV. Do not be afraid. If you have more ones, you can just define them inside the RAT, the Robox AGV tool. And so you may just have a complete fleet of AGVs. For this sample, we are just making an easy structure, so we will just put one AGV. But if you have more, I will show to you how to copy and paste to make just other ones. Now, let's begin with this structure. We have 1, 2, 3 and 4 motor wheels. Every motor wheel is an object which is composed of 2 axes. One is a steering axis rotating over the Z axis, while the other is the traction axis that will pull the motor, and so it will pull your AGV. For this reason, the motor wheel is some standard device for AGVs, and here we already have in the main project 2 ones. But luckily we already have other ones here. And since today we are just simulating and I don't want any problems, I will just enable all of them. Now, let's first of all make some connection. Here we have, we need to set the motors for these wheels, otherwise we will get an error while compiling. So let's enable the ethercat and let's just directly use, okay, let's just copy and paste this sample. Let's save as, and we are making not a 2 motor wheels but a 4 motor wheels file. In this 4 motor wheels file we are just going inside, we are checking, okay, it's a 4 millisecond sample interval system, that's good. And now we are making copy and paste again, and once more and once more. Our AGV has 4 motor wheels, and so it is an 8-axis system. Now let's just connect all the motor wheels and move a little the axis to let the graphics to get better. Now the names, okay, we can just update names. number 5, number 6, number 7, and here number 8. Okay, now you see we have all of the axes we need to make our system able to run. Let's make it more beautiful, let's save and let's close it. And now in the AetherCAD configuration, let's just come here and choose from our folder the 4 motor wheels. Here we say 4 motor wheels, 8 axes. Very well. Confirm. Now we need to come here and check. Okay, axis 1, 2, 3 and 4 are already connected. Number 5 will need a connection too. So we are just opening here. As you know, the yellow boxes are the ones already selected, while the white ones are still available. So let's choose number 5. Then of course status word and control word here of number 5. And let's come here and check for the current position stuff. And this is, oh sorry, this is a traction wheel, so we are not looking for position, but we are going to use a speed reference. So traction will request a target velocity, and here, okay, current position, that's just something we may read, position, current, no sorry, position, actual value, that's enough. Alright, let's check the actuator is in fact a speed reference, and here we have all this generic stuff. Very well. Number 5, number 6 is now looking for this. It has some old stuff inside it. We are just replacing it with some new stuff. So status word and control word of number 6. You see that part is just something you need to repeat. Steer axes are controlled in position. So don't be afraid of seeing this difference. And we have position, actual angle value, okay, and position reference is axis 6, target position. Very well. We can come here and see that in fact position reference is set. In the steering wheel we would like to have a control of position, while instead in the traction we are just moving according to position. It says there is this new resource and it's asking us if we want to rename all the other occurrences. I'd like to say yes. Maybe it will be risky, but I like it. Number 7 will have the same problem, so let's just choose this. Open 7, take the status word, and then open 7 again, and see the control word. And now link to 7, that's a traction. So no, traction doesn't want, current position, yeah. My apologize. And here speed reference, in fact, that's number 7, target velocity. Finally, again, replace all the occurrences, and last is number 8. Let's complete this stuff. Let's make all of these requested current position. Oh, sorry, number 8, control word. Nice, and here we are linking to number 8. Number 8, current position actual value, and here we have a position reference for number 8. Nothing else, position reference, and so on, and everything is ready. Then all of these axes have to be connected to the power set. So now let's come here. This is all part for the motion of the AGV. So the motion should go all together. Let's check axis 4. Is having all of these can open AetherCAD configurations, and now we are copying and doing the same for axis 5. Alright, no, this is can open and can open. Number 6, our friend, the same here, and here. Very nice. Number 7, you are not escaping from me. All right. And finally, number 8 is not going to be forgotten. So number 8, here, 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 and also this one. Very well. Now, alarms and so on is already set. Let's confirm. Let's save the workspace. Let's check the hardware is the RP2, and up to now we do not have any axial line module, no serial communication. Let's just go out, and today we also do not have any I/O. Sadly, let's take it out. Okay, let's confirm. And here in the IP address, now we have these advanced settings. All right, here we have a lot of things I absolutely have no need to use. So let's come here, configuration, let's go in IP address, and I do not want the advanced configuration, I just use the base with IP address. Disabling the advanced configuration, all its relative data will be removed. Okay, I don't care about this. IP address, I just want easy fix, and now just connect to ATH number 3, and let's write, that's my IP address, and let's also put stricter mask, I'd like it. Confirm, now right click and generate all. As we see, everything has been generated correctly. Here we just use these standard motion axes, and so we have no need of any other auxiliary axes. In case you have, you should add them here, add them also in your Ethercat connection, and of course create a new power set. You may copy and paste this one and use it to control the auxiliary axis. Let's keep them separated because this is the motion power set and it will only be used to rule over the AGV motion axis, so the wheels. All the others will stay in another one. If you have any questions, contact the Robox staff to get more. Now let's just take a look at the program. Here we have the rule. Let's go and let's check. This is the mask of virtual axis, mask of axis in motion. Okay, maybe we'd like to define something more. So we have maybe parameters. Okay, no, there's nothing important here. Let's go to the begin here. Some operations, some stuff, registered parameters. General lit, okay. Here in the general, we will find some other things. And so here we have all the masks. So the traction is now the mask of the axis used by traction. Is now 5 because it's 1 is in binary 1, 0, 1. So only these two. Now I cannot select together, but these two. And now we also add these and these. So this becomes 0x55, while the steering will be AA. The mask of the axis in movement will be FF, so all the traction and steers. Auxiliary axis now, they do not exist. This is just an example, and here inside we have a mask of 4 axes used for a lift, so that's something useless, we do not care. Other stuff, virtual axes, are something we do not need. The C0 done mask is now using AA because all the steering will need the 0 cycle. So 2, 4, 6 and 8 axes. Now here we have some pages for the RDE configuration, but that's something we are not using. Let's say we are not going to check this stuff. Let's save and let's go back. And now let's, for example, see what happens. I will, oh yeah, we need to go to the task number 1. One important thing we have to do is to set the motor wheels. While we do the init motor wheels, here we have to check this function. This is very important. Here we set the the motor wheels and we set which axis will be used for it. And as we know, here we already have some structure using the X and Y position, and here it's an index. Let's see, this kind of index will be used here to write the meters per turn. Now here below we are creating some motor wheels, and we are setting position, setting the maximum speed, maximum acceleration, the bit of the encoder. All of this stuff is something you have to write on your own. You have to check the bit encoder, and here maybe you will have the maximum RPM and the traction reduction. This is the round motors coming, the gear, the ratio between the round per motor, making one round of the wheel. And finally, later we are going to set also the sides, the circumference of the wheel, so how many millimeters is one wheel cycle do. Here we are so lucky, we already have defined these other axes, and so we will have front, let's say, front left, and here this is front right. Okay, and then rear left and rear right. Very well, and here we have a motor wheel, steer, offset, and so on. And here we have some register, steer, offset, all right. This is to make motor wheel to choose closer geometrical solution. Okay, that's something, that's just something we are not caring too much. Let's see who is calling this function. And here we are again so lucky because the system is already expecting us to have more motor wheels. And here we have plus x. Here we should say plus x minus y, and then minus x plus y minus x minus y. So all the four possibilities. 1, 0, 1, 0, 1, 1, 0, 0. All right. And so for this reason, now we have almost done everything. Thanks to this, we have already set that our AGV will have 4 motor wheels initialized. We already know all the data of these motor wheels. Here I just would like to check inside the lit reg, which is the registers.i3. Let's check it here. And that's here, okay. Here we only have these 2. Okay. Real register, the value is kept also in power of some kind of offset. And maybe later, maybe we would also need steer, offset, and VRR index. Okay, no need. Let's say here there is a 0, which is a standard value. Now, I'm sorry, I do not exactly remember this value, and so I will just set it 0. Or maybe later we can let's define them. We have 5 and 6, and we now do not have, we have 8 and 9. Let's define, for example, 3 and 4 that I see are still available here. Let's check if I'm right. And VRR4 is not existing, and number 3 neither. Okay, so let's just copy these 2, and they will become 3 and 4. And this, I apologize, it's Italian, so AS is front left, front right, rear left, rear right. Now let's save. Let's copy this, and let's say this is PS and this is the PD. So we have all the possibilities, and they will be saved. Now, we have told the AGV about the motor wheels. We have nothing else to do because all the rest part of the HMI and automatic stuff is just standard. We just need one last thing, and that's to come here and check the values in the lost reg and the parameters we would like to use. Let's open the lost reg and see here we have just a few information. NVR index of the vehicle. Of course, this is set to 0 because setting it by hand could be more safe. Every AGV must be set according to its vehicle number, and so by standard is 0, which is not valid, and we will need to write it on the shell during the first boot. So please never write it here, otherwise you will load the lost reg in every AGV of your fleet, and all the ones will think to answer to the same number, and that's something that must never happen. Then we have the parameters debug STP, which is the name we would like to use during the load of the parameters, and here we have, so in this file we have some other parameters. Here we have the name of the map, alright, and so here is something we will write. We just call it Robox map AGVM. This is just the format generated by the RAT. Then later we are doing some other stuff, we are looking here around. We have some parameters, some expert parameters I suggest not to touch, and here we have some other registers. What we need to do now is to check the position of motor wheels. So let's go back to the index and let's look for these values. This is here. Now the X and Y of the motor wheel are set here. And now, here we know every motor wheel is using an X and Y system. Remember that inside the AGV, every time we are thinking about the reference system, we must remember that X is an axis going front and Y is an axis going, and Y is an axis going up. That's because we will also have another part which is Z, which is the axis getting out from the screen. I'm sorry for my not so stable hand, but I'm just making an RGB, red, green, blue standard reference system. So this is an X, Y and Z. This is X, that's Y, and that's Z. Alright, so this is the system we use. So remember, the first motor wheel we have to define is the traction front left. It is said to be here. So let's take a look. I draw it wrong because actually my Y is not respectful of the right hand rule, so I must move it away. And let's just do this, just rotate, just move it. All right, and now I'll put it here below. Very well. Now, so the first wheel, as expected, is this one, the one which is the front left one that in fact has plus X and plus Y. Now, plus X and plus Y from the center of the vehicle, plus X is 2 meters and plus Y is 750 millimeters. All the values have to be set here. So X is 2 meters, while Y is 0.75 millimeters. And so we have the position of the motor wheel in X and Y. And according to the fact that here in task 1 we say plus X and plus Y for one motor wheel, plus X minus Y for the other, and then all the other possibilities, we are perfectly able to set the position of all the motor wheels. In case your AGV is not using a motor wheel, but is using an electronic steer or just a tricycle, so a triangle structure, or you use an electronic steer or tank wheels or any other kind of wheel, please ask Robox staff to give to you a corrected task in which instead of this init motor wheel function, you will be provided with another function suitable for your kind of wheel. Now, let's come here and let's imagine we have a magnetic antenna. Every AGV may have one or more magnetic antennas in case it has an inertial navigation. Since the inertial navigation is the most stable, the most precise, the most reliable, and also economically very convenient for customers, we always propose it. It's even better and more precise than nowadays SLAM systems, and even if they are more comfortable, the precision reached by the inertial AGV is so high. So in the inertial AGV we would like to play the antenna, and so we may have now it's written, we have I'm sorry again for the Italian names, but this is the antenna behind and the antenna in front. That's because an AGV may have from 1 to 4 antennas. We are simulating an AGV using antennas, but sadly now I have no antenna because I'm just simulating on my desk, and so we are not going to use it. Let's just copy this and go to the task 1 and oh, sorry, we are not using it. That's so strange. Let's search for it. Yeah, I'm not using it. Very interesting. Okay, this means that here, while we are making the init of the AGV, we can go and see the various parameters, the geometry, and here, while we set, okay, here we can see different settings, okay? In case you have a natural navigation, you will have, for example, in this case, a Rexroth LLS rocket system, and here we already have a function. Here instead, we would like to use gyroscope and antennas, and here we would like to use a LiDAR lock connection, a SICK LiDAR lock. In this case, we would like to use an AGV, so let's go and check it. Here we set a lot of registers. Here we would like to set gyroscope. And finally here we have the antenna. Okay, this antenna position is NVRR number 40. That's okay, the same here, just the name was wrong. But now, as I said, sadly, now I only have my Robox RP2 controller here on my desk. I have no antenna, no gyroscope, no LiDAR lock, no Rexroth. So I'm sad we have to kill them all. Let's go to find here the serial antenna and I will set it to 0. Otherwise I will have many errors while booting the system. So I have no gyroscope, let's kill it. Now here we just kill the serial part, but remember now the most updated Robox hardware for both antenna and gyroscope are EtherCAT devices. So you have no need to use these serial parts. Let's take a look at all of them and copy and then look for them here. 000. All right, now let's go here, serial. Gyroscope is something I already set to 0 here. And finally, I also would like to check we do not have any other thing like LiDAR lock, the address. Okay, so here we have the LiDAR lock connect. And that's something, the connect address is nothing. Very well. Here there is a port, but we are not asking. Okay, it's just a string and that's 0. As you can see, string NVSR number 10 and that's 0. Finally, the last thing was the rootkit connect. Let's go and check, that's also 0, it's not even set here. In case it would be another string number 13. Here we see it's not even set, so it's not a problem for us. Very well, this should be enough to let our system work. Now, we save. I already save everything here. And now let's go to Programs, right-click and compile all. Let's hope everything should be normal and stable. In the task 3, we are going to have, now I want to show to you, just an RDT function. Here inside we are going to handle some stuff due to the connection to the RDT, so to the HMI. This is a standard function, so you are requested not to touch, otherwise you may break something important. But if you need to add more pages and more function to your RDT HMI, you will be allowed to feed this function at the end of the universe. Here we go, and here you may increase, you may add other stuff, or if you want and you want to make something even more clean, together with my system handler RDT AGV function, you may write your own user RDT AGV and call it and put inside everything you need. Now let's come back, and here that we did everything, I should already have and my controller switched on. I'm now looking, I now do not have the correct connection, so let's go here in my TCP IP connection, and that's mine, 10.0.33.1. Okay, and that's BMW, yes, which is not a car, but it's my name, Bassignana Marco Walter, so don't be afraid, we are not controlling any car now. So let's try to connect, let's say ALS, and in fact we are not communicating, boring. Let's see what I can do here. I have to check my RP2, I say check communication, Ethernet number 3, and that's exactly what I need. So it's just Windows making me some bad joke and not allowing me to correctly connect. Now let's see if the cable is good, take out, take in, and in fact it's good. Fuck it. Okay, right, let's keep going, let's say ALS. Okay, this was a previous program, let's just do power allowed equal to 0, and now let's load our system. Now here inside we have the F8 that we are not loading because it's already fed up with another simulation, and so it's not important for us to erase this because it's the same RHW file inside and we have no need to modify the RTE operating system. Here inside you may see we have disabled some A9, G2 and P2020, 3 different versions of the operating system RTE. Normally, while you buy your Robox control and you also have the SD card with inside the standard folders, you will find the F8, and inside it you already have the correct version of the RTE system suitable for your controller. But in case you lose it or you cancel it by mistake, you may look for it on the internet and just download it. Remember, you may just use your AirSUS software, which is here. You always have to open this. You can open the catalog, and in case you do not have the RTE, you can wait it to connect to the internet, of course, letting us playing some seconds. Okay. Here inside we will go to see the news, and we can see all the softwares. You can check the software you already have installed on your PC, and you may install new ones. Now, for example, it's suggesting me a beta version of RDE I do not want. If I ask show the complete catalog, I will see more things. Here, for example, we have the RDT runtime. This is something necessary you have to play on your PC, so I suggest you to choose the latest one and install. Now I already have it installed, so I don't need. If you want to modify the HMI, you will need the RDT tool. So again, you may would like to use the most recent one. Or if you are using an RDE version which is newer than the 355 0, you will have the RDT already integrated inside and you can use it here. Otherwise, you can just install and use the previous one, that is a separated device. While you have every one of these three, you should be ready. But for the RTE operating system, you can come here and see the new RTE. And here you may choose A9, G2 or P2020. You can just click the ones you want and press download the files. In that case, remember the difference, because different motion controls have different processors. So RP0 and RP2 have A9 processor. RP1 and Micro RMC2 have G2 processor, while Micro RMC3 has got a P2020 processor. If you have any question, please contact the Robox to get more information. Now here you can see we have all of these files, some override file, and here there is a standard map we do not want to load on the project, and so they are cancelled. You can press space to enable or disable files, while instead in case of folders you can do the same. You can press space, enable and disable. And so now let's just do a rebuild. So of course, I will never check the F8, otherwise I will kill the RTE and then my system will be no more able to start. So, just FA, FB and OB. Close everything, set loading mode, do all of this stuff, and let's confirm. Let's do it. This will be a long procedure because we are loading a lot of things. Normally, if you have to load the project of the AGV over your system, I suggest you to just make a device image, and you can do it here like tool, generate the device image. You can know more looking at the RDE online lesson I already made in some of the other videos of Robox SPA. And here inside you just make a device image, then you just copy from your folder, just clicking here. Maybe I already have one. Let's check here in the project. Image. No, this I didn't do. So in case you may just make it here, then just copy and connect. Plug and play. You will need a SD card reader. Plug it to your PC, just paste your files inside it, and that's done, and you will be ready to play. Now that our system is loading, sadly we see now we have to put the RC AGV object blocks and then the motor wheel object blocks. They are big files and so they will request a long time to be loaded. But don't be afraid that's something happening only now. That's the first time we would like to make this rebuild. So remember, if you want to avoid to lose that time, please just make a copy of your files from PC and just use an SD card reader. And it's making it quicker. Now, while it's loading these files and we already set all the files as emulated, I think we should be able to quickly connect to the system. But in order to do this, let's start doing some other important part. And after we have made the R3 project available and so 99% of what's inside a AGV is done, we have now to play with the DSpan. Now, the DSpan is the HMI. Let's open. Here is something you may download from the internet. You can go in the AGV, you can make things in order of last modification, and so you find the compiled files, BDF. To understand where they finish, I just made them related to be opened with the Notepad++. They actually cannot be read by Notepad++, but that's just useful to see this green icon, and so it's easy to understand it's not the same as the pages. Together with them there is this autoexec.txt, which is a very important file for the HMI. You can know more about this watching our RDT lesson. Now, let's say that I just copy these already compiled files and I come here in C, Robox, RTM, where I have already installed the RTM. Current version is 2.2.12. I go inside projects and I have already made an AGV RDE folder and I paste here those files. I go to the upper level, sorry again. Here inside I must make a project folder. So I need then to make Ctrl+A, take all the other files and put it inside. That's because together with this folder we have some other material. If you want to know more about how to do this procedure, there is a README file I have written with so many informations in details. Please read it, because every time you will make a phone call and ask me to help you doing this, I will just tell you to read it. So, here, IP address. The IP address is something we can find here. Copy and paste. And now this is something we may edit. Our IP address is 10.0.33.1. Let's close it and keep it here. Then we would like to have the alarm definition files. Here we copy and paste it too. Now please pay attention, inside the alarm definition we have def alarm English and Italian. These two files should be the same as the ones here, def alarm English and Italian. Since these are standard projects, these two should be already the same, so I have no need to update. But in case you make your own alarms and you here will need to write your English or Italian or any other language text of alarm, you will need to copy your files in this folder, otherwise the system will not be able to see them. Alright, apart from this, we should be almost ready. And here everything is done very well. Now, let's go up, and here in this we can start the RTM file. But first let's come here, let's edit this. Okay, I already wrote here. The project I want to open is AGV RDE. So, that's done. Now, the RP2 has already correctly booted. And let's start here. Oh, sorry, RP2 is not actually correctly booted, it's just making the first boot. As you have already learned in previous videos, we have an alarm history loss. So, since we see this alarm, we already understand that the HMI is correctly connected. I just press erase. I think I'm not allowed, sorry, I must press it hardware because the software is not yet started. This alarm is stating us that the RP2 understood a new project has been loaded in the SD card. This means that while I press the button, the button on the RP2, the advanced button, it will erase the alarms and let us cancel the previous project stored in the memory of the controller and load the new one from the SD card. Now, this is ready. We have the emergency button pressed, we have the Rig 8. Rig 8 is the name of the HMI, emergency button pressed. Of course, we are in simulation, so normally in these cases I'd like to have some kind of debug file telling me not to stress so much us while we are playing. Here I do not have any other kind of information. So in this case, since I do not have any debug file, we can do it. So let's just open Notepad, let's open this, and let's say this is the debug file. Use it in simulation. And so now in simulation, we will, for example, go and find this kind of inputs. Let's make an easy research. We are now having alarm 1160 and 1161. So, okay, I understand. Let's go here, programs, task 3, alarms. and we would like 1160 and 1161. Let's copy. I can just search here in all the current documents. Oh, it's not happening in any other. So that's a file I still haven't opened yet here in the editor. Let's copy, paste, and find it. Task 1. This is just a test of alarm, and here in the rule we have the alarm set. Yeah, that's exactly where we want to find it. Now, let's close this useless window. Let's go and check all these safe. This is a variable telling us we have this input. Okay, here we have input emergency from this pan. We will have input from bumpers, but we also have some bumper disable. Okay, emergency this pan is that kind of input we may easily find. It's an I/O, so we go in AGV I/O. Every kind of project we done in Robox has almost the same names, so registers are saved in the registers or lit reg files. I/O are saved in the lit I/O or this kind AGV I/O. And alarms, again, will have some easy to understand name file. Now we come here and we see we have this file. So let's copy this line and we see this was, we have also the deadman of this pan, that is the rig 8 button. So the other alarms, these two ones are the ones we need to copy and force. The input word is number 40. So let's come here and let's make it easy. So first let me save it as here project. Now let's make it a debug.stp file. Here we have a lot of interesting stuff. Okay, we can save it here. And now here we say input word 40.6 equal 1. Then we give 2 spaces and we finish. And here is number 7. All right. These two, I'm sorry, I'm not sure. Maybe I have to force them, but it's maybe not so important. Now let's take a look. We will play. Now, let's go to File in Flash, right-click on FA, and we make New File. We search debug.stp. Now we'll load it inside, load in Flash. Nice. And now we do exebat/fa/debug.stp. And we see executed do. Oh, successfully done 0. That's not beautiful. So maybe we need to do something else. Yeah, I need to force. All right. So I need to force input word. And so, okay, in case we need to force this input word, maybe I just need to force it to, they are, let's say this is something useless, and this is 0x. I need to use bit 6 and bit 7, so this should be a C0. Alright, let's try again. Let's easily copy this, paste here. Okay, now let's say dv input word 40, and that's a C0. That's something nice. Now here, maybe I can reset. And yeah, and that's done. Now, oh, now sorry, here we are doing some problem because we would like to see the zeros, but C0 done equals 0xAA. We force it, and now we are in manual. Yeah, I'm sorry for this, but this system wanted me to go manual, and now we are simulating, and it was fighting because I already had the zeros of the first 2 axes, but not of the other 2 ones. the steering axis. Now let's go again to the main page, and now since we know that this command made it correctly, because now we are on power, we are in standby, we are in manual, and we can see the power set. If you know from the previous lessons, while the power set has 0x12 inside it, we know we are on power. 0x36 is also having 12 inside it. So the bit 10 and bit 2. This means we are on power. We can see as debug a lot of these very beautiful bits. Now imagine I will force again this input word. Imagine I force the input word to 0. So I kill it again. Now I have again the alarms, and we can see we have some red bits we cannot enable, and that's telling me we have something wrong. You may see these bits in order to understand what is missing to your system in order to get on power. Now, let's force again this word. Then, since this part is good, let's do not forget to load again the correct path of this debug.stp file in memory, clean this no more useful stuff, and now here we are in manual. Now we are in missing power. I just press this sometimes, going on power, and now we are in standby. So people, your AGV is correctly powered on. Now let's just take a look at this HMI. You can read the manual to get more information, but since we are here, we can make just a brief introduction. This is the init page, so while you switch on your HMI, you will see this page. In this very beautiful picture, you see a digital background with this one that was the ancient dispan. Someone of you may have already seen it on some of our older AGVs. Now we are using instead the touch panel, the beautiful HMI, and so this kind of device is no more used. Here in the icon of the home button, at first there is a hourglass, which will remain here until the system has been correctly booted. Let's press it. Now coming here, we can see the main page. And here let's see some settings in which we can see some information about the AGV, about the parameters, about what's inside our system, the zero cycle, and here we may change the language. Here English, Italian, French, Spanish, Portuguese, German, and Chinese. According to the language you prefer, you may choose one of these ones. If you want to use other ones, it would be just your own easy duty to add it in the RDE project and then load it. Here we can see the I/O, but since now we are simulating, we have nothing. In case you have a rig 8, so like this, our HMI, in this page you may have a little debug of I/O buttons. You can just press on the various lights, on the various buttons, the physical ones, and see if here the contacts, the LED is switching on. Sometimes they may be disabled at the boot of your RTM, and in that case you will not see them working. It would be a pity because the power button is very important if you want to get on power, instead of pressing the reset button of the alarm window. And then V plus and V minus will allow you to increase or reduce the speed of your AGV, while these two arrows will make you control manually your AGV and make it steer right and left. So here we have the debug window. The debug window is very important. Here you can have some important windows. Now I will just use my own secret password. And so now here we do not have other buttons because they will show up only if you have other devices like the gyroscope and the magnetic antenna. Since now we are playing just a sample, it's just an RP2 with nothing connected, we have nothing. Here we can check the motor wheels. We have motor wheel number 1, we have traction and steer. It's type motor wheel. As I said before, you may have a tank a single wheel, you may have a tricycle, you may have an electronic steer. So here we know the position, here we see the direction. The direction is a sign, so you may check it. If your drive is connected in the reverse mode, you can modify this bit just to make it move forward or backward. I suggest to you the first time you switch on your AGV, keep it lifted from the ground in order to be allowed to play manually and avoid it to escape from you. You are never sure your AGV will behave in a correct way, so please make yourself safety, keep the AGV lifted on, keep the wheels not touching the ground, so even if they go to hell, they will not make the AGV to go to crash against anything and anyone. Here we can just see all the other wheels, so you see front wheel, front right, rear left and rear right, and everyone will show us the position according to the correct sign they have. Alright. Now let's go back here and let's see. Here we have, for example, other system pages. Here we have some parameters. These parameters are related to the same stored in the parameters debug. Keep in mind every time at first boot the AGV will execute the parameters debug file, and this means that all of these values will be overwritten. If you want to modify one of them, you will just do it to play it runtime, it's just a test. If you want them to be forever kept, you must write the same value also here. If, for example, you do not like 0.3 of speed here, and you would like 0.5 because you would like to move faster, then means that this is the automatic traction speed, and then later you must come here. I already know the name of the parameter I'm touching, so I'm going almost, it's later, and I will have to reach here the speed of automatic traction, and here I will need to write it at 0.52. Otherwise, if I just play here, I can play it right now, but next time I will switch off and switch on, the 0.3 written here will overwrite me. So I have to save and then close. And of course, do not forget to load it in memory, otherwise it will not be updated. And at the next boot, I will keep 0.5. Now, for example, let's go and check other things. Here, for example, we have some messages, and here below now we have no gyroscope and no antennas. Otherwise, here there would be a very beautiful table showing us the addresses, the station numbers, and other things related to them. And here the AGV number. As I said before, AGV number 0 is not allowed, so we must press it here and write 1. This is AGV number 1. Now let's go home again. And let's go to log. Here we have the log, and so we can see here all the messages. But as we can see now, there is no text here inside. That's a pity, and that's my fault. Let's close it and let's solve quickly this problem. Here we have to go back in project. Here I go in AGV RDE, and here there should be a etc folder. Inside the etc folder I will put the alarm def. If I remember it correctly, this is the correct path we have to use, and so here we must put the alarms. I'm so sorry before I made it wrong. I hope you are watching all the video and you reached this point so you know the truth. And now in fact we can see all the text of the alarms. In case we have some system alarms like this, or this, we can see also here some description and some hints on what to do. If you have your user alarms, you maybe would like to add some kind of description file. That's your own possibility. Here, for example, I can take in and take out this window below with the description. In this case, I can have all the window to see the alarms. Here again, we can filter. We can hide or show the warnings, like here. We can hide and show the minor alarms, like this one. And here we may hide and show the major alarms, so the ones blocking the system and making a power fall. Here we can save a text file of our log, and here now it's again requested to write my password to have a level 5 and being allowed to use the erase button. If I use it, it will be requested to confirm. I do not want, of course, but in case I press yes, I will erase all the history of the alarms. Now let's come back here. Here we have some statistics about how much time and space and distance the AGV has done. Thanks to these statistics, we may check how long AGV has been working for, how many kilometers you see here, meters here, and here totally some time working automatically, power on, and total time. Very nice. Now finally here we have an oscilloscope. Here we just see some values. Okay, here we have the speed, the second is Y error, the third is the angular error of the AGV, that's the IP2, so the one of the steer, the first steer, and that's the second steer. Now we do not want to add other variables, and so we just keep this. Now sadly we are just simulating on our RP2, so I'll not be able to move the AGV, and for this reason we are not able to see anything on the oscilloscope. But while you play on your own you can see something. And again, since I'm not playing with a real AGV, I do not have any battery, and now it's showing me 0%. Of course, this is not possible. And if you have your own battery, you may write the battery status according to what you expect inside the task 3. As said before, let's close some of these files in my RDE stuff. Here I should have some part just checking here. The battery, this is a system value, and I can check this value according to some values in order to check the battery state. And in this way, I will make this, to change this picture. Finally, the most important page is the manual page. Here I'm in manual already. If I press the automatic cycle, now I have an error because I do not have the plant map. I'm so sorry. So, yeah. And now here I can say forward and backward. Sorry, this is slow and fast. And here I have forward, backward, and not moving. After some time, even if I press forward, after some time I have... sorry, something is getting problem. I'm sorry. So after some time I'm not playing axis, it will go back to 0, to stop, so there is a timeout. This button instead will change from manual steer to automatic steer. The automatic steer will use the gyroscope, if any, and so it will force the steer to stay at 0. While we use the manual steer, we may press right and left to move the steer, while pressing 0 will allow us to go back to the 0 steer. Here we have the advanced settings for expert drivers. I suggest you not to play it unless you are allowed by Robox staff. And here we have some other stuff. Here we have the manual. We can go to configuration mode, sorry. That's a special rule you may use to play some of your axes. I suggest you just to use it if you are allowed by Robox programmers. Here we have motors, and here we have some jog commands. Up to now we have just the first two motor wheels, both steer and traction, while instead other axes are now just put here as sample. You may modify them as you want. Finally, here again we go to the same parameter page as before, and here you may set something about initial point, configuration mode, automatic and manual mode. And finally here you have the tuning page. That's very useful. While you first switch on your AGV, you will be requested to make the 10 meters tuning procedure. If you don't know the 10 meters procedure, please contact the Robox staff to learn more about this. But let's say that this procedure is something you will be requested to do in order to check and to set the space made by each rotation of your wheels. So it's checking the circumference. And you are making it very, very precise. You must do this procedure the first time you switch on a new AGV for the first boot, and then you will save. In case you make maintenance on an already existing AGV and you substitute wheels, remember that the new ones will be, of course, wider because all the wheels have suffered warning, and so they have been scratched and their circumference is smaller, and for this reason you will need to do again this kind of procedure. To know more of this procedure, you can read the manual of the digital dispan, or please contact the Robox staff so we can play together with you. Now let's go back and let's finish this. Mainly you now know everything about the introduction to the digital dispan. If you want to add more pages for your own and to play on your own and to make other functions for your customer, you are free to do, always using the same folder. So here in material, here in the dispan, you have the project of the RDE. You may just switch it on and play it and modify. That's not something I'm going to do right now, but keep in mind that's possible. Okay, now that's done, and now you should be allowed to move. As I said before, in this situation with a real AGV, you should go in configuration mode and maybe just play with some predefined command you may create on your own, maybe going here and pressing this and this. Now we cannot because we are in alarm and because we do not have a real axis connected. But here you may move the axis, tune your drives, and so you can check that the directions of your wheels is coherent with the physics of your system. You can check that your steers move left and right in the correct way. You can check the position of the zero reference of your steers, and that moving your traction wheels, you will make the correct distance. Keep in mind that traction wheels have the same revolution, which is only 1. Since now in the configuration you just move axes one by one and you have not done yet this 10 meters calibration, because this will be done later while you will put the AGV on the ground. Now that you still are not allowed to do this, you must just move jog in configuration, I said, all of your tractions to see that in fact you can tune axes, that the gains are good, and since I say that their revolution is standard, it's only 1 round, so it means that every time you can just come here and see the IP. You can take a pen, make a scratch, make a line just to read, just to see it on your wheel, move it of 1 turn, and after 1 turn the line should be in the same position as before. If you made it correct, it will be like this, and you are okay. Remember, 1 line, you put the line, you draw the line, you make 1 circle, and the line is in the same position. That's because the IP and CP of all the traction wheels is moving in units, and 1 unit is 1 round. Instead, remember, for the steer, traction is this one. So traction is this one, so if you want to see the position, you will need to see the CP or the IP in the shell. That's something easy. You can just say dv cp1 and you can read it. Now, of course, it's 0 because I do not have a real axis. While instead the steering wheels, they move in degrees, so you can just measure the angle with some kind of device, of ruler, rotate it to plus or minus 90 degrees and see if they are correct. While this unit the KB2 units are correct and the directions of the wheels are all correct, you are allowed to take out the configuration mode, put the AGV on the ground, and now you can start moving forward and start watching how does your AGV behave. Here remember, the speed of manual is this one, slow speed, fast speed, and as I said before, here you may modify it. Now I have this alarm so I cannot, but you can use that kind of speed and you can modify them just to play. And pay attention to the values you write. Here you have acceleration, deceleration, and if you want, you may also have a manual jerk, even if normally it's not used. Finally, here you have a feed rate. Feed rate can go from 0 to 100, so 100% is maximum feed rate. And if you want, if you are using the Rig 8 HMI, you can press V- and V+, and each press of this button will increase or decrease the feed rate by 10%. This is something that is always allowed. Now you know everything about the dispan and about the main tuning of your AGV. You should have finished. The last part you may would like to do is to set the AGV manager to begin a new project and being able to move your AGV. Now we open the AGV configurator. Now the AGV configurator wants to deal with the previous project, so now I press enter and then I press alt. They must be clicked separately, otherwise you will open the property window. Here I can say change directory and okay, let's copy, let's paste, let's press enter and select the folder. And now here it says demo random move, that I think is the one, yeah, AGV lesson. Okay, let's get inside. So this is demo, let's call it demo AGV. Today is 28 November 2023. The main language is it's English, United States. And now we have to set here inside the AGV manager folder, we have to check the X script main XS, yeah, that's the main script. Here we would like the execution, not important. Emulation, yeah, that's important. Nothing. And then map. Map will be, I would like to check here. Here we have nothing. So first we have to do the map. And then we will check again here the manager. Nothing important. Here this should be important in order to load the map to our vehicles. But in order to set this, we must know the string of the map version and the R to reload. This is the kind of things we can see again in our RDE program. So let's make it easy. Let's go to the register. The address may be a little different, but normally it's the same. There is trigger, I'm sorry for the Italian name, trigger ricarica mappa. It's request to reload the map when the AGV goes in missing power. So this is R19, so integer register for map reload R19. And here the string for the map version. And that's at the end of the universe. We go here, string map. Description of the map, compact flash path of the map file. Okay, we would like this, I think. And so SR3. String register for map version. Is it correct? No, sorry, software, yeah. For map version should be this. In order to check it back there, let's say DVSR1. Oh, sorry, I'm no more connected to my RP1. Now I have to plug again. And now, of course, we will need some time. Go to timeout. Ask it again. All right, SR2, no map loaded. SR3, okay, so by sure we want number 3. That's nice. So other stuff is not important. This is very, very important, but actually if you have a real AGV, this will let you to load the map by the AGV manager. But remember, we still do not have the name. And here, AGV is 10, 0, 33, and 1. Okay, in case we have other AGV, do not forget they will have .1, .2, .2, .3, and so on and so on. And the order must be the same. Here we can check serial, ZigBee, but of course we would like Ethernet, TCP, or UDP communication. No PLC, no database, no problem for this I/O description. Save and quit. Now the map is Robox map.evm. That's the name we would like to load. So let's just use ret and let's create an easy map. So in this case, we make a line and let's just define the points. So this map will start in 0, 0 and finish in let's say 20 meters 0. This way we have this line. All right. And now let's make it easy. Let's put just an initial point. This is a pointless. No, let's say, yeah, that's just 0.1 meter point. Just put here as end of the line. Then imagine we would like a station. So here we do station, for example, let's call it 200 and we give it a name. This is the parking point. And the position of this point is 1 meter. Now after this, let's say that here we do another line and okay, now here another, and here another. Yeah. And now we do some crosses. So normally always click first on the horizontal, then on the vertical. So the quadrants order will be 1, 2, 3, and 4. This is a standard of mathematics. If you press first the vertical and then the horizontal, you will make a not standard situation and it will be a little more strange to deal with. Let's make all of this line and let's say, okay, on quadrant number 1, we would like a curve. And the speed can be limited to 0.3 meters by second. Now we do the same here, and let's search number 4. Oh, now you would like to modify the language. I see it's Italian. I'm looking here if it is possible to change the language. I'm sorry, I can't see any language properties, but okay, quadrant number 4, modality, curve. Luckily, all of these technical terms are the same, and so it's not a problem. And here again, let's say 0.3. And for example, okay, here again, we do the same in this quadrant. We only want number 3, we want the curve, and again, let's make it 0.3 meters by second. Finally, here we are playing with quadrant number 2. And again, we make a curve. Now we have all what we need to make this circular path. Now, for example, let's imagine here we put a station and that's at 6 meters. The station number will be 20. And then we put another station and that's, okay, in 11 meters, it's called 11, correct? No, that's 20, that's 21. Very easy. And so this is, we can also put some name, but now I don't care. Remember that the code is compulsory while a name is not. And here we put just a generic point. For example, in 12, it's so close, let's say 12.5, okay. and then let's put another, for example here in 15.0. And now just take these 2 points, and I want the AGV to move always in counterclockwise direction, so the allowed direction is always forward. Again, I'm sorry for this Italian part. Now let's see if I can change the language. I need now to go to our folder, so I will just copy the address from here, Ctrl+C and Ctrl+V. Let's get in here, and I will call it Robox_map. This way I save the XML file, and now I can generate here. Okay, and it tells me created file of the map. Now I'll modify the language to English. Okay, I right click on rat on properties, and here I have found the trick. I just need to add -us to the rat destination, and so it will open in English. Now I can open again the recent project, this Robox map, and now we can go back and work on this. I was taking these 2 points and saying that the allowed direction is only forward, and any orientation. Now let's say that orientation is again only front. In this way, even if by mistake an AGV is not moving in a front orientation, it will be not allowed to go after this point. Now let's see, for example, some other stuff. Oh, we need to put an AGV, so let's put it here. And then here we will talk about the dimension, okay, 1 meter, half meter, and here we set the color. I'd like this AGV to be blue, so let's choose it. All right, very well. Now this dimension is not really important because the real dimension of the AGV will be set in the AGV manager. But anyway, let's make it respectful of what we have done. So here we say it's 4 meters and 1.5. Actually, the rigid body of the AGV is even bigger, so we would like maybe to add another half meter just to be sure. So 4.5 and 2 meters. So let's say 4.5 meters and 2 meters. This will be a wide AGV. Okay. Now, because of this big AGV, I'm quite sure that actually these kind of curves are getting a little too much short, and the AGVs will not be so happy to curve so much. Actually, this is just a fake AGV, so it's not a real problem. But in case of a real AGV, we must take into account that it may have a maximum curve angle, and so we must prevent this. If possible, longer radius curves will make it easier for AGVs to move. Now here, between these two curves, we would like to add another generic point. Okay, let's take out these pointless numbers and let's put it here. This number will be very useful for the AGV to break its motion while it's reserving the path. In the same way, after the curve, we can just put another point here, 15.5 meters. And now, for example, let's just add this station 10 and just make it, okay, 12 meters. And then here we have station 11 and station 12. So station 11 is going at 10, no, sorry, I wrote it 1 meter, instead it should be 10 meters. And this one, for example, let's go at 8 meters. They all need a code, so that's number 12, and this instead is number 11. At the end of this, we may again put another generic point. And so, okay, this is coming here. Here we have the curve, and here again a generic point on the line that is very useful in order to have a stopping point in case the AGV is not allowed to reserve more path. And now I think we have enough. Okay, we may just add another point here, and we may just set it at 8.5 meters. Now, just to make things a little more funny, let's also add one more point here and we call it 201. And that's parking 1. Here in this point at 19.5 meters, we stay here, and now in quadrant 1, 3 and 4 we enable the curve. In this way, the rotation. In this way the AGV in that position, while we'll need to go back, it will be allowed to rotate on itself. Rotation, rotation, rotation. Very nice. Now, let's save. The map needs a name. I call it Robox map for demo of 28 November 2023, and I always like to write the time. So while I will update the time, I will take into account also this. Transversal navigation I can enable. Now we are not using, but in case we would like to use it, I prefer to have it. And so that's done. Let's also go to check the vehicle. This is just another little model, and that's good. Simulation, map, okay. Save and generate once again. Now it's done. Let's open again the AGV configurator. And now we can go in map and choose the map file, roboxmap.map. And now we are happy. Now save and quit. And finally we can start playing the AGV manager. Let's open it. It will tell me I have to recompile the standard code. Okay. That's done. I'm so happy, but this window is so big. Can I make it smaller, please? I cannot. Okay. Now, after the first compilation, it will ask me to reboot. And so here we are. Now, let's take a look. Now I make the installer. You see, I press the key and I have clicked on installer. Now, since I am installer, I have the complete control of all the system. Normally, you may use a password, as we have seen in the configurator. But if we do not do it, that's not important. The AGV is now here just because of emulation. But imagine we want the AGV to be raised. We have to make it to initial point. So I show you again. I click on this emulation control. I go on vehicle 1, and here I can set the initial point. Now I'm emulating it. So the AGV, I can say I want it on line 1, and here it's position 1000. It must go forward. And so let's go automatic. Yeah. Now let's close. And let's ask the AGV to go up to the end. I move and I see that the distance is 18,500 millimeters, so 18 meters and a half. We can see the AGV is already reserving this distance, moving a little, and as we can happily see, as soon as we start playing with AGV Manager, we are already able to drag and drop our AGV and it will move over the map. In case you have a real AGV, you will have instead to do 2 steps before this. You must go to installer, and you have now here it's not available, but there should be a button with a blue picture saying load map to the vehicles. Here now it's not present. Let's check if I can enable it in the AGV configurator, even if I think I should be allowed. Map drawings, scale, enable map loading to vehicle. Oh, sorry, flash folder of the map is FA. Maybe this was important and so missing. And okay, save and quit. Maybe this was something very important. Let's become again the installer, and I will see the generic points and so on. But still I do not have that flag. So here there should be also this other point where I can load the map to the vehicles. Anyway, coming here, I can see my map version. I can see I'm loading the program and see here some settings. This is the things. happening. And here we have the Robox map. Sadly, it's not telling me the name. I'm so sad. All right. Oh yeah. Now we are emulating. So actually, I should take out the connection to vehicle. Otherwise, I'll do something very terrible, because I should have together the emulation and not. Now, in case I want the AGV to come here, it tells me I can have one at E99. This means I'm no more able to go to this point. And I'm not able because I have no other way. You see, I cannot go back to this point. And I cannot go back to this point because I'm in a dead end. That's because the only way to come back is here, to go forward and front. Now I'm still in the front orientation because I'm coherent with the line. You see, the line arrow goes right, and my AGV is pointing right too, so it's front. That's coherent, but only forward means one way this way. I'm not allowed to go leftwards. So this means that I cannot go back. And now I would like to come to this point, but seems, as we can see, that I'm not allowed. Now let's take a look. Here I have all the rotations. Here I can check this. Okay, and now let's see. Okay, so here we can first increase the speed, that's making easier. All right, and then let's go to the map. Let's check here. Okay, it's not occupable. Yeah, if the point is not occupable, means I will not be allowed to rotate. So let's say yes, I'm allowed. Yeah, I'm allowed to occupy this quadrant. Okay, and so now I will be allowed to rotate in this point. And together with this, it's not so nice to have a station as last point. Let's always put a generic point just to have a limit to the line. In this way, the AGV will never get out. Let's change the time. It's 16:42. Let's save. Let's generate the map. And let's play again. Alright, now let's get here, let's choose our AGV, and here now I'm allowed to rotate. The AGV is coming back, and as we have seen before, I'm not allowed to come here and then doing the curve. Now it has to rotate. Oh, sad story, now it's rotating in the wrong direction. That's so boring, and that's also even more boring that the AGV is now moving so slowly. Here we have time, so I can make it much faster. I was hoping that thanks to the parameters before I was making it faster, but then now we have this little problem, and now the AGV is not going anymore to be in the correct point. Now, because of this problem of these 2 points that will pretend the AGV to move at, how can I say, the AGV must arrive here in front. You can see direction is front, orientation is front, while other points have direction X, so anyone, orientation X, so anyone. Of course, the AGV will never be again front, and we can see there is no other way the AGV can get front. So, until this point it's possible, 13 meters and something. Here it's 18 meters and something. And here we can reach this point. Okay, in this way we can also reach because we will move on the other direction. Oh, what a nice. Look, the system, since here we didn't put a one way only, the AGV is finding an interesting solution. That's something so nice. The AGV is coming here, it's going, rotating itself. Now let's make it 10 times faster. And okay, after this, now the AGV, oh, it's so slow. Let's keep speed at 5 per to make it faster. And now we can go to begin. I think the AGV is so small, according to the dimension we expected now. So let's take a look at the code. Installer script. Or let's make it even better. Let's close here. Let's just take a look at here. We can open the X script. And then we can also open, no more this one, no more this, and the common part. Let's move the common to the other view, so we can have them both. Now, as we said before, the common part is just using some standard command, some standard macros, and system stuff, some X functions, and here we have just some boring things and some pre-deployed parts. Now we have some micro to wait, to set destination message, and some abort in move, check, move to user, and so on and so on. This is a standard library we should normally not use. While here in the X script main, we have all the things we need to know. Here we have the on application start. As we know, this is mainly the constructor. Here we can check the map, and here in fact we see, as we said before, we want symmetrical dimension 4.5 meters and 750 millimeters. Alright, then we may add some handicap for curves and for rotation. This means that while the AGV is moving on the map, it's calculating the best route to the target point. And in order to do this, it will use some handicap to increase the calculated path according to rotation or curve. So per each rotation, the AGV will add 100 millimeters. And per each curve will add 2 meters. In my opinion, it's too much. Let's make a reverse. I prefer to give more handicap for rotation, because rotation is more time consuming, while instead the curve is just 200, because it's, yes, something slowing down a little the AGV, but sometimes it's necessary. So imagine our map is much more complex. Imagine now we are not really doing this, but imagine we are doing many more lines. Okay, now we are not making all the lines, but imagine like a city where there are many lines in here. And imagine my AGV has to go to this point, starting from here, the beginning. Let's imagine the AGV is coming here, then maybe it will be able to make a curve here and go up, a curve here and go right, a curve here and go up, and again right, and again left and up. Why should the AGV choose this line instead of getting always straight, just one curve and getting up? That's because of this handicap. So this handicap will find that the always straight path with the last curve and always straight vertical is the best solution possible, thanks to this handicap. While we move backwards, we have an handicap factor for segments where the AGV will move backwards. Let's say that if we put 1.5, we intend that we do not want the AGV to move backwards. That's something, for example, for some AGVs like triangle AGV, where moving backwards is not such a stable movement, we may put here a very high factor. In this way, the AGV will calculate the minimum possible distance to go backward, and if possible, 0. Here, I'm sorry, this is a flag whose name is Italian, but I can assure that there is also the English new name. This is deprecated. This means it is okay to stop at a minimum distance before the cross. And so let's say in this case 1, I hope This is in meters, I'm not sure of this, but we may press Ctrl F1, and in this way we can open the manual and we can ask here the X map, and here we search this B, this is the distance, let's search the distance. Okay, it's this one here. Oh, minimum distance in order to stop before or after a cross to reserve the movement. Okay, it's not what I was thinking about. Okay, let's let it here. Then here I say, this bit is saying, is it okay to make an inversion over a cross point? And now I say true. Okay, I will allow this. And then I say, in case there is a pallet, so actually a product, on the path, it will be locking me. Oh no, let's say false. In this case, maybe the station, I imagine a station where the product is on the side of the line, and so it's not locking my run. And in this case, we can go forward even if the station has got the product. While instead, other times, in case the station, now I'd like to go back. In case the station here has got a product and the AGV is coming, in case this is a locking product, the AGV is not allowed to go forward. It must either load the product and go forward, or if the AGV is already loaded, it should either put its current product down, take this and go forward, or just give up and do another path. And then here AGV position threshold. Okay, this is again something I'm sorry, I do not remember, 20 millimeters. And then we set these parameters to map. And here we have the set movement length. So 12 meters is the distance I wanted to book. Let's make it smaller. Let's make just 5 meters or 7, a little more. Let's don't be too much strict. On application stop, there is nothing, but if I want, I can get some file parameters and then save them on some kind of files. Here on next mission, as you can see here, there is written nothing, and that's just making some safety checks in order to see that the AGV exists. And then here we should, you see here this comment, to do. We had to find a destination point. And after this, we will check if the destination exists, if it is an active point, and so generate a mission to that point. That's good. Now we have registered mission, and up to now here again, we see in this demo project there is nothing. So here we have no mission, but in case we have something, here we have to list all the mission macros of the current mission, case by case. You may have seen the lesson about the theoretical AGV, and you have seen the example where we have a lot of missions here listed. In the same way, now we can go to on update.io where there is nothing. And on AGV drop at point, as I said in the other lesson, this is a predefined functions where I will make some safety checks, and if everything is good, when AGV is dropped to point, I will just register the mission to that point. And that's exactly what we do in our AGV manager. Let's open it again. Let's, first we need to compile the script. Compile, everything good. Now I'm sorry, when we compile we have to reboot. Alright, now the AGV is exactly what we were expecting. So now it's a long AGV and we will move it, no, it says rear, I don't want it rear. You see, now rear is more convenient. So it means that up to now we still have some other bad handicap. He is choosing to do rotations sorry, rear it's correct because the AGV is curving. Okay, now it's a long AGV, as we said before, a longer curve is more comfortable. And now it says that the AGV is rear. just because we see the line is going from left to right. We can see here on the right. You see the arrow is showing us the 0, so the origin of the line, and it's telling us the direction. So now the AGV is moving with the AGV direction, which is reverse, so it's rear. Now again, if I move it, you see on user point 12, and inside parentheses we can read R, which means rear direction, and the distance is 4 meters. Let's move the AGV, and here we are. And now, okay, let's for example go here, and we are going front. That's because the AGV is making the curve, is coming here to station number 20, even later, stop, and go back to this position. As we can see now, the AGV is so big, it's still occupying the cross. So this means that this station is not good in case we have more than one AGV in this plant, because another AGV that imagine it's here in station 12 and wants to go down to number 20, and we know we would like to move only in one direction, so counterclockwise, will be forbidden to reach this station because this AGV is locking it. So, if you have to make a plant with more AGVs, please keep in mind this part. Now let's just move it to this generic point. And alright, now let's for example make the last part of this interesting lesson. Now for example, let's go here, let's take a look at all of these functions. We were saying register mission. On expand macro, here you see we have almost nothing here, just some common handler, and then here we have no macro because this is the empty code you download from the website, so it's the standard code. Here you have to invent your own macro and use them as you need. And here the same for micro, we have just something, some moving operation, and then nothing. They are just divided according to the kind of the operation, the microtype here, but each microtype will have a select, and inside each of them there is nothing. And then we said on update IO also has nothing because we have no IO. Status change, again nothing. AGV dropped to point, which is the main function we are using now to test the AGV. And then let's see, let's go back to where is on next mission? Yeah, here. And now let's invent our mission. So here, for example, let's close the AGV manager again. Do you want to confirm? Yeah. Let's imagine we would like to see this destination. Okay. Now let's make an easy mission. Here we have two stations. We have 20 and 21. Here on the left we have some filters. If I take them out, you see I can enable or disable the things I'd like to see. In this case I want to see lines and stations. In this case also user points. And here starting points, magnets that are not here, battery points not yet, and cross points. Okay. Now let's just keep everything but not the generic points. I want to see the users. Here we have 21 and 20, and here we have 12, 11 and 10. Okay, so we have 20 and 10 as the main points. So let's define mission codes, macro, and here something global. So let's say define ID first, let's say first station, line 1, and that's 20. And then let's define the number of station, ID first station, and let's say the number of station, line 1. and we know they are just 2. All right, and here, and then we do the same for the other line. So let's say the first station in line 2 is 10 and the number of station is 3. So we go back here, yeah, 3 ones and 2 ones. So now we can save. I'll just copy these names, go to the next mission, and just let's create our sample program. So first of all, I'd like to have another int. I need the current line. Oh, I hate current line. So let's say that current line is AGV, maybe I do not remember. Let's see, AGV, no, line, it's getting not so nice. Get map, get site info. Okay, maybe I already have inside vehicle information, but you see, if I ask vehicle information, it will tell me UAGV. Okay, and no, but guess what? I already asked this here, so it's pointless. So let's just let's check it. Let's check here inside this information, Control F1 to open the manual, and here vehicle information. Perfect, this is what I want to see. U line ID. So the current line is just is equal to vinfo.uline_id. Did I write it correctly? uline ID. Yeah, nice. Okay, so that's everything I need to know. Because now I want to say, if the AGV is in this line, so in line 1, I will choose a station that is here on the other line. Otherwise, I will choose an AGV, one of these 2 stations at random. Let's close here and let's say destination, if current line is, let's say it's equal to 1, so I will request destination to be the first station in the line 2 plus a random of the number of station in line 2. All right. So this is a number getting between 0 and 3, not 3, so between 0 and 2. This should be integer, so integer, and here I'll keep it like this. I'll add more parentheses. I know they should be useless, but that's something interesting we can do. Otherwise it will be done the same for line 1 and line 1. And then let's just make and if. Very well. Let's check what the AGV manager is doing here, and let's see if this is happy. Okay, installer, edit script, let's compile. Oh, something terrible happens. Okay, he just wanted, I used too many parentheses. I have save. No, variable expected. Yeah, I'm using this. I'm telling you it's integer number. No. And so, okay, let's not use it. Anyway, the system will make itself integers. Okay, and now it's saved, compile, and that's good. That's enough. Now I have compiled, I can kill it, I can make it. Now let's see what's going to happen. Let's enable. Oh, now yeah, the AGV is going up. I didn't put the one way only in the map. Now it's here, and now AGV is choosing this point. Yeah, so every time the AGV is generating a mission, we can go and see here. Now it is generating again a mission. 12, 21, 11. So while the AGV is in this line, it will choose one of these two stations, and while the AGV is here, it's making a random, choosing one of the 3 ones above. Now you understand it's quite easy to write something about load and unload. In case one of these 3 stations has a load, has some kind of product to be picked up, you may save the current time and then ask which one has made the request first and just ask the AGV to go unload, and if the AGV is loaded, just go here and unload. As you can see, making this kind of demo is quite easy. If now I right click on the AGV and I say disable, it means that AGV will finish the current mission and then just stop. You can see here the stopped button telling us that AGV has been stopped. Now, if I come here, drag and drop, now let's just enable and make it go again. Very well. So this was mainly a very interesting demo of AGV Manager programming. I really hope you understood what's happening and how easy it is to play with the Robox system. I suggest you to play on your own. As you can see, you just need the AGV Manager, the RAT, and you can just play it on your PC. I did not need the use of my Robox controller on my desk to play that kind of demo because the AGV has been emulated. But in case you have a real AGV, you may just connect to the real one, make the initial point in some way on your map, and that's done, and so you are ready to play. If you have any questions, please keep visiting our YouTube channel on the internet and write us an email for any kind of commercial or technical question you have. Thanks for your attention and see you in next video.